Welcome back, hyperbolic coding chamber participants. This is day 16 of the daily LeetCode grind. Another day, another dollop of misery on this planet, just floating. Reflections on yesterday. I did symmetric. I dropped a video yesterday. It was called Symmetric Tree, more like Symmetric Free. But in all honesty, I got bodied. So I got fried. You know, the problem wasn't free, actually. It cost a lot. It cost a lot of time and energy. And it's a lot of energy I didn't have, actually. So, you know, we got fried. I clicked fail. So, you know, we should get that problem again. But it's sitting on my forebrain. Wondering if I should hop back on it, maybe. Give it a shot and reintegrate that knowledge. But who knows? I know my next rep on it is July 5th. So maybe I'll remember that Q solution then. If not, we're just going to have the rep time anyway because I'm getting fried. But that being the case, we got some problems, some old problems due that I don't know if I'm going to go very deeply. I think I'm just going to try and solve them as fast as I can. And then after they are solved, you know, I'm just going to jump into it and try another problem and try, because this timer of 40 minutes that I'm going to say is going to be a mixture of both. It's going to be both. It's going to be my total time that I have, you know, to do problems today, which is unfortunate, but it is what it is. You know, it is what I have to give, and this website will accept what remains of my sanity. So 2 problems, power of 3, first unique character and a string. And then, you know, maybe we'll jump into add 2 numbers, which I got fried by last time. And then we'll do majority element missing ranges. There's a lot of ways to do this much better than the way I'm doing it, but I just don't have, you know, I'm going to do what works. You know, as a wise man once said, do what works. I used to try and do like, you know, people say like grind this amount of time or just do the problems or just do this or that. The system that I make, although convoluted, is what works for me. So I just have to go for it. And this is what allows me to do it every day. So, you know, it's always a battle between wanting to run further, but not running so much that you don't want to run tomorrow. And I'm going to be honest, this is harder. LeetCode is harder than running. Someone's got to say it. This website, this is harder than running. Running's pretty difficult. But that being said, I'm going to jump into these problems. And so I'm just going to jump into the first problem. We're just going to start with power of 3, the goal. Time complexity is big O of log n in the worst case. And constant log of n in the worst case. Time complexity, a constant space complexity in the worst case. So problem. And I'm going to start my timer. Make sure I'm recording. The function is power of 3. We're given a number. We have to return if it is a power of 3. An integer is a power of 3 if there exists some integer n such that some integer x such that 3 to the x equals n. So 3 is a power of 3 because you can do 3 to the 1 and you'll get, or 3 to the 1 and you'll get 3. 9 is a power of 3, 27 is a power of 3. So what we're really doing is a search over whole numbers between the range of 0 through n. Since our search space is sorted, we can convert this into a binary search. So let left equals 0 and let right equal n. These would be the boundaries of our binary search. So our left is less than or equal to right. We're going to calculate our pivot. I used to call this mid, so I wrote mid there, but we'll call it pivot. It's going to be left plus math dot floor of right minus left over 2, and we have to floor it half because when we can choose between 2 pivots, in the case where we have something like this, you know, what should be the pivot, 1 or 2? When we floor, it's always going to be 1, so it's going to be left leaning. It additionally helps when you do 1. So you'd right minus left. So left would be 0, right would be 1. 1 minus 0 equals 1. Divided by 2 is 0.5. And you can't subscript an array with a value that's not whole. So we have to floor it, just get a value that we can even use, right? And then we have our pivot, but our pivot is really going to be x, right? Where we said 3 to the x can equal n. That makes something a power of 3. So one way to make that is we're just going to say value is going to be 3 to the x, right? And we're going to say if something multiplied by, when you multiply something, the output of the result of multiplication is called the product. The result of exponentiation is unknown. So if value equals n, right, that would mean that, you know, let's just say n or x equals 1. 3 to the 1 equals 3. 3 does equal 3, which means that 3 is indeed a power of 3, so we return true, right? Else if, right, we want to have our search space on each iteration. So if value is greater than n, right, then we want to have our search space, right? And so right is going to get the value of right equals pivot minus 1. And then if value is less than n, left is going to get the value of left equals pivot plus 1. Minus 1 and plus 1 because we already processed pivot and we want to skip it, right? But setting it equal to a pivot is going to cut our search space in half on each iteration. And at the end, the number that we want to worry about, right? So there's a case where, you know, this does run that we want to be careful. So let's just say if they want us to check whether or not 0 is a power of 3. Well, that's the case. Left will equal 0, right will equal 0. 0 will equal 0. We'll calculate our midpoint, which is going to be 0. And then 3 to the 0 is going to equal 1. So we're going to go all the way down here, right? And 1 is going to be greater than n. And so we're going to say pivot right equals pivot minus 1 and pivot equals 0. So right is going to equal negative 1. And so in that case, we're going to get out here and we may want to return false, that it is not a power of 3. Cannot find name x. This is supposed to be pivot. Should double check that. Let me double check. We have left, right. Left is less than or equal to right. Pivot left plus math top floor right minus left over 2. Pivot minus 1. Pivot plus 1. Looks good, I think. So this should run in log of n time because we're going to have the search space on each iteration with constant space. So the goal for this problem is going to be linear time with constant space complexity. We have first unique character, we have a string and a number. So given a string s, find the first non-repeating character in it. And if we want to find the first non-repeating character in it and return its index, if it does not exist, return negative 1. So our input, first non-repeating character is L, and the index of that character is 0. And the first non-repeating character in this one is 0, 1, 2, so it should be V. L has two occurrences, O has 2 occurrences. So you can't do any better than linear time here because you have to check the entire string. And so what you need is probably a map, right? It's going to be a key value pair of letters to occurrences. And we would iterate over every character in the string. And we would populate this map. Then we could iterate over the string again and check for each character. If its occurrence equals 0, then we'll return the index for that string. So we're going to populate the map here, and then equals 1. So const value equals const value equals, so if the map already has a value set for this character, actually an even better way to do this in JavaScript would be to map.get sub car, and this can potentially return null, and then we use nullish coalescing to set it to 0, and then from here we can do map.set car value plus 1. This would be shorthand to populate a map. Now all you have to do is iterate over the string and return the index if the currents equals 1. So I think there's a shorthand for this. So we want to iterate over the string. We'll do idx and car. I always forget if idx goes first or if car goes first. And do s. And we're just going to print that just to see if that looks good. And then we'll return 0 just to appease TypeScript. It's going to fail, but I just need to check. So this returns a character, but the right side is undefined. So likely what we want to do is we're going to spread this into an array. Then we should be able to get the index and the character. Oh, spread it into array and we'll do .entries, and then we should be able to get index and the character simultaneously. That looks good. And then so here we can just check if map.get car, which will give us the occurrences, equals 1, and we'll return idx. Otherwise, we'll return -1. So we can test this with LeetCode, const map. So we're going to create a map with letters to numbers. And then we're going to do const car of s. So we're going to iterate over every character in s. So we're going to start with L. Does the map have the value for L? It does not, so it's going to get the value of 0. And then we're going to set L equal to 0 plus 1, which is 1. Then we're going to go to E. Doesn't have E, so we're going to get E to 1. We do have E, so we're going to get map.get E here. It's going to go to 2. And then we're going to put T into the map. It's going to get the value of 1. C is going to get the value of 1. O is going to get the value of 1, D is going to get the value of 1, and E is going to get the value of 3. Iterate over the string again. Then we're going to get the character, get the occurrences for the character, so L. And L should be the first number in the map in the string that has an occurrence of 1. And so we can return the index. And if we can't find it, we'll return -1. This looks good. I'll return this in linear time. I don't think you can do better than linear time, because to check if you have to visit every string, every character in the string. So that's going to be linear time in the best case. And so yes, it also will not be, it'll also be constant space even though we're using a map. As we can see that our constraints consist of only lowercase English letters. So for any arbitrary large string, we're going to use a constant number of spaces, number of values and of keys in the map, which is going to be 26 keys. So we'll pass that. We have no cards due. I say we try add 2 numbers again. And we probably should. Let's try it again. Linked list problem. I don't know what my problem originally was with this problem. I couldn't solve it, but I'm going to try it again now. So we have function. We have a list node to this definition for a singly linked list. We have val and the next pointer, right? And then this will set them to undefined, right, if they don't exist. Or if they're undefined, it'll set them to null. So add 2 numbers, L1. So we have given a first linked list, we're given another linked list, and we're supposed to return a linked list. You are given 2 non-empty linked lists representing 2 non-negative integers. So 2 non-empty linked lists, so you don't have to worry about them being empty. And the digits are, and they're non-negative, so they're positive numbers only. the digits are stored in reverse order. So I guess 243 actually represents 342. Each of their nodes contains a single digit. Makes sense. Add the two numbers and return the sum as a linked list. So we should be adding 342 and 465, and the result 342 plus 465 equals 807, but they'd like us to return the answer in reverse as well. Return sum in reverse. You can assume the two numbers do not contain any leading zero except the number 0 itself. Any leading zero except the number itself. 1 to 100. So you potentially up to 100 nodes. And the values are, the symbols or the values are between 0 and 9 inclusive. And this guaranteed list represents a number that does not have leading zeros. So we could have, I think the way I went about this before, we could have a function, we have two linked lists, right? We can get the values out of these two linked lists, right, simply by using a stack, right? We could get 342, 564. So we could get forward ver of L1, right? Get forward ver of L2, sum values, and then since we've summed the values, we need to reverse the string. Maybe reverse sum as the string, and then from here we could just create LL from string. So we get the forward version of L1, forward version of L2. We have 342 and 465 as nums. We'll say as nums. We'll sum the values, so we'll get a number, and then we'll reverse the sum as a string. It should be 708, and then we can create a linked list from the string. So I think we can start by creating a function which would be called reverse LL num, and it's going to take a list node, and these are guaranteed to not be empty, or it does not. A linked list can be empty. Oh no, yeah, the node. Okay, linked lists always have at least one value, so you don't have to pretend that they could be null, right? And we're going to return a number. And so the goal here is just going to say cur equals LL, right? And we'll say while cur not equal LL, and here what we're doing is we want to get the forward ver of LL as a number. And so what we could do that is with a stack. And I was using an array. Let's try actually using a stack. And what we're going to do is we're just going to say stack dot add. So the node is guaranteed, the lists are guaranteed to have at least one element in them, and we're going to use a stack. I'm not sure if the way to add to a stack is add or push. We'll try add first, and we'll do cur.val, right? And then we'll take cur to the next node, right? From here, we should have a stack representing the value, so we should be able to just iterate over every element in the stack. Or actually, it's actually easier if it's just a list. We'll just do stack.push cur.val, so it's going to be an array of numbers. And then since it's an array of numbers, we can take stack.map, and we're going to have a number, right? And yeah, I guess, yeah, I was trying to use a JavaScript version where we can just do num or const num as string, set it equal to an empty string, and we're going to iterate over the stack, right? And we'll just do stack.length I plus plus. And at each point, we'll just do num as string plus equal stack dot pop dot to string. And then here we'll have the number in reverse. We should just be able to return parse int of num as string. And just to test, I'm gonna do console.log of reverse ll num of L1 and see what I get. I'm just gonna return null for now. Oops, and you can't add to a constant value. And this is a colon. Yikes. So standard out puts out not a number. So while, oh, I said cur does not equal LL, cur does not equal null. So I'm getting 342, and so 342, yeah, so we're getting 243 as input, and we're getting 342 as a number as output. So that works. So we'll say const L1 val equals reverse LL num, and then we'll just pass in L1, and we'll duplicate this for our second half. It'll be L2, so we'll have the numbers, and then we'll just sum them. Do L1 val plus L2 val, and then from there we have to reverse the sum as a string. So we'll have the sum of the values, and so we can add these together, and then we'll map over each number, turn it to a string. Maybe you can't map over each number in a, we'll just turn it into a string like this, and then we'll do I would just take the sum as a string is the goal here, and I'll set up a quick binding. So sum as string, and so we'll spread this into an array, and then here we can just reverse the sum, and so the sum will be an array. We just have to reverse the array, and you can do that with, you know, or it is actually similar if it's just simpler if it's just a string, and we just have to iterate. So I equals sum as string dot length minus 1 while I is greater than or equal to 0, I minus minus. And then we'll just have const variables get out of hand so quick. We'll just have con let sum equal an empty string, but this is actually sum as string, and we'll just say sum plus equal sum as string sub I. So this is the reverse sum reverse sum as string part, and then we should just be able to console.log sum. And length is not a function, it's a property. So we're getting the right number, so we have 708, and so the final thing we just need to do is create a linked list from it. So we'll just say function create LL, just going to return a list node. From a number or from a string. We'll just call it num as string. And then what we'll return is create LL of sum. So we're passing in a string. And so to create the node, the linked list, we'll do a starting node, which is just going to be, we'll just call it root, or we'll just call it LL, and we'll say new list node, and we'll say for const num of s of num as string. So here we just have to convert it to a number. We'll just do the parse int of s, and we'll say ll dot val equals num, and then we'll say ll dot next equals new list node, and then we'll say ll equals ll dot next. Then we'll have head, which equals ll, and we should just have to return head. We need a way to keep track of the front. So ll.next. So we'll just run it real quick. So we know we get 708. We'll create ll. So we're getting passed in 708 as a string. So const ll equals new list node. We're creating a list node. We're going to keep a reference to the head. So we can return after for const s of num as string. So we're going to get 7. Parse int of 7 as a string is going to be 7. ll.val is going to get 7. ll.next is going to be a new node. And then ll equals ll.next. So now we're at a new node. Now we're going to be at 0. We're going to parse 0 as a number. It's going to be 0. And so the value at that node is going to be ll.val equals num. And then ll.next, we're going to create another node. And then ll equals ll.next. And then we're going to be at 8. We're going to turn 8 into a number. ll.val equals 8. And then ll.next equals new list node, which should be null. ll equals ll.next. And then we should have nothing. We should be able to return head. So I'm going to run it. Can't assign to L because it's a constant. And I have a 708 here for some reason. So 342 plus 465 So maybe at the end, since we're getting an extra value, we could set ll.next You could also do this with the for loop, which would solve this problem. Say let I equals 0, I is less than num as string dot length I plus plus, right? And then we'll say if I is equal to num as string dot length minus 1. Then we'll always create that list node. Otherwise, we shouldn't. Alright, so first solution looks good. Oh man. So our second one does not look good. So we have 1001, 465. So something is happening. So we're getting our reverse LL as num works fine. Sum as string. Let me console log sum as string. Just to see where I'm failing here. Okay, so we use 1e to, okay, I see. So because the nodes can be up to 100 numbers long, it's not as simple to just do basic addition, because you get 1e to the 30 instead of the actual number that you wanted. So one way we could do this is we could do school book addition based off 2. So the way that we're going about this, we're getting 1e plus 30. I wonder if a big int could store what I'm looking for. The sum as string gives us 1e30. Sum as string gives us 1e30. If that's the case, maybe a big int could help us. Let's try. I actually don't know how to create a big int in JavaScript. Let's try this. Okay, so now we actually have the correct number. So big int was the correct play here. We're getting 8656 at the end, which looks a lot like what they have. But my output seems to be wrong somehow. What they're outputting is 10466. But there's not even a force. If you add these two numbers together, it's not even a 466. Not a 466 in it. So it actually could, I'm actually realizing that my addition of my numbers is way wrong here, because this is giving me like crazy value, but 1 with a bunch of zeros, and then 1 plus 465 should be 466 actually. So maybe the goal is something like big int L1 plus big int L2 val, then we'll wrap the whole thing in a 2-string expression. Yeah, I'm getting a crazy number each time, so I'm just off here. And the number I'm getting as a value just doesn't make sense. So I don't know if big int is big enough to store a number that large. So I could go and I feel like what you could do is implement like a school book edition that takes two linked lists and could add the two numbers together. Then it could have a carry and everything, and it probably would be a perfectly fine system. What we could do is with could implement the two linked list summing instead, because our addition is just wrong here. If we did that, maybe that's why they said our linked list values do not contain any leading zeros except the number 0 itself. If that's the case, maybe they're trying to show us that what you can do is iterate through both lists. So 5 plus 2 equals 7, 4 plus 6 equals 10. You put the 0, you carry the 1, and then you add 8 here. So maybe there's no need to actually do all this addition stuff. And the reason they're saying there's no leading zeros is because you can literally skip to the shortest linked list. Let's remove all this nonsense, and we're just going to say, let's add two linked lists node by node. To do so, first we need the length of both, get length of both linked lists. Figure out shortest and longest, and then from here we need to move longest to where shortest starts, to be the length of longest minus shortest, and then from there we can sequentially iterate and carry numbers. So we need to add two linked lists node by node. First thing we need to do is get the lengths of both linked lists. So we could reuse, we don't need this create LL function since we're gonna probably just going to use one of the linked lists, and we're gonna reuse this. Now I'm going to bring down this small piece here. I'm going to reuse this reverse LL num function merely because I think what we're going to go for is actually just count the linked list, number of elements in the linked list. So we're just going to say let temp equals, let her equals L1, delete the stack, not doing anything with that. We're going to say CT plus equal 1, delete all this extra nonsense, and then we're going to return CT, and then we'll get L1 length equals count LL. So count LL equals L1, and then we'll say L2 length equals count L2, count LL of L2, and then we'll say const longest equals if L1 length is greater than L2 length, then longest is just going to be L1. Otherwise, it's going to be L2, and then the shortest is going to be, so if longest equals L1, then shortest must be L2, otherwise it's L1. We figured out the shortest and the longest. Now we just move the longest to where the shortest starts. So we'll say the movement is going to be equivalent to the number distance of the math by absolute value of longest minus shortest. So we'll say I is less than whatever that amounts to. In this case, it would be 0 because they would start at the same length of 3, and since they start the same length of 3. We don't really move anywhere. So longest equals longest dot next. And then here we want to sequentially iterate and carry numbers. And then what we'll actually return is going to be a reference to the longest head, which starts, so we'll just say head, which equals the longest is what we want to return when we add them. So here we just need to sequentially iterate over both linked lists, and since they're the same length now, we should be good. And I'm going to make this example just a little more difficult just so you know what to do. So I'm going to say the number was 2, 4, or 1, 2, 4, 3 plus 5, 6, 4, and longest would be starting at 2 here. And then we'll make sure to add this other number 1, 9, 4, 3, and 5, 6, 4 so that we know how to handle overflow. And so the way the school book addition is going to work is that the numbers are already reversed, so we don't have to reverse the linked list forward, right? We just have to add as it is because we already have the numbers in reverse. So 3, 4, 2, and okay, I think this is what they want us to do because it's already set up. Writing 3, 4, 2, but it's already reversed for us, so we can school book addition carry going rightwards. It's a little too natural, so I'm thinking this is what they want us to do. And so we'll say sequentially iterate and carry numbers. We actually don't have to worry about it because it's actually going to be like this. The numbers that we're actually adding are always going to be exactly where we need them to be, so we don't actually have to worry about carrying forward or backwards in this case. That is to say that 3, 4, 2, 1 actually represents 3,421, and writing that to 465. Not 1,243. So it's perfect. Oh, because the next node, if it exists, we could carry it if it, okay, perfect, okay. So that being said, what we'll do is we'll say while shortest does not equal null, right? What are we gonna do? We're gonna start at 1 and 5, right? We're gonna start at 1 and 5, so we're gonna change longest dot val, right? Or we want to check, right? If longest dot val plus shortest dot val is greater than 9, right? We're gonna do something special. Otherwise, we're just gonna say longest dot val equals longest dot val plus shortest dot val. We have 2 minutes left. So in this case, we'd get 6, right? And then we want to take them both to the next iteration. Shortest equals shortest dot next, and we'll duplicate this line and make longest equal longest dot next. And both of these are null, so I'm going to change them to let. And then we go to the next iteration. 2 and 6 would be 8, 4 and 4 would be 8, and then we'd be done. But let's do this one, right? So 1 and 5 would be 6, right? But then 6 and 9 would actually be 14. Since it's greater than, let's just do this. Const sum equals longest dot val plus shortest dot val. And we can simplify all of these statements, do sum, longest dot val just equals sum. If our sum is greater than 9, it equals 14 here. Then what we want to do is maybe we'll do if it's greater than 9, we want to do value minus 9 or value minus 10. If we do value minus 10, we get 9 plus 6, which is 15. 15 minus 10 equals 5. but you actually would carry 4 in this. So 9 plus 6 is 15. You want to carry 4. So would you do it by 11? So we'll say if sum, let's handle the case of 10 first, right? Sum equals 10. So let's just say this is 9. 29. So let's just say this is 9 and this is 6. And we ran out of time. But let's just say this is 9 and this is 1. Then it would equal 10. In that case, we want to set longest dot val equal to 0, and then we actually want a carry, which is going to be, and then we're going to set our carry equal to 1. Right now, since our carry is equal to 1, and we're setting that current value to 0, now we're going to do 9. I'm going to make it a little bit easier. I'm going to choose one more number, do 3 and 4. So 3 plus 4 is going to be 7, plus 1 is going to be 8. It's not going to be greater than either of these. So if longest.val equals, if it's not greater than 10, then we just maybe want to set carry equal back to 0. And then in the case where our next case is not actually less than 10, then we'll do 9 plus 1 equals, so 9 plus 4. We actually want to carry 13, so sum does not equal 10. Else if, right, sum is greater than 10 is the case, you know, we want to handle here. If sum is greater than 10, then we actually want to say carry, sum would be great, it would be 13, right? So you'd want to carry 3. And so we want to carry 3, and our sum is 14. So we would say carry equals sum minus 11. Because 14 minus 11 would give us 3. And then we'd have carry equals 3. But our longest dot val would also equal 0. In this case, because we'd have 4 plus 9 equals 13. Oh no, in this case you would actually, wait, 4 plus 9 equals 13. I'm getting confused because I'm adding this in reverse. The actual thing we're adding is 3991, 546. We're doing it in reverse. In this one, you get 13, you put 3 here, and then you carry the 1. So you'd put 3 here and then carry the 1, right? And then you get 15 for this and then 7 for this. No, actually, no, I'm going in the wrong order. You actually go, right, you go from reverse. Oof. You go from reverse and you'd add 7. And then you get 4, right? You get 14. And so you'd subtract not 11 from it, you'd subtract. That would be sum minus 10. Because you'd get 14, you'd subtract 10, you'd get 4. And then what you'd carry would actually be 1. I think you carry 1, and you get 14 again. You get 14 again. And then you carry the 1, you get 447. So 391. This looks like this makes sense. So the goal would be usually carrying the 1. So let's just run this for a nonsense number, like the number we just mentioned. So we'll do 3991 and 456. So that would be 1993 and 654. And this wouldn't be longest minus shortest. It would be L1 len minus L2 len. And so shortest does not equal null, right? Because it'd be starting at 6. And we would say the sum of longest dot val, which is 1 plus 6 equals 7. So it doesn't equal 10, it's not greater than 10, but it does equal 7. So longest val equals 7, carry equals 0. They both go over one node. Then we have 9 and 5. 9 and 5 equals 14. The sum is not 10. Sum is greater than 10, so carry equals 1. And longest dot val equals 14 minus 10, which is 4. And then we go to the next one, and then the next one, so carry would equal 1, so we'd have 1 plus 9 plus 4 equals 14. Sum does not equal 10. Sum is greater than 10, so carry equals 1. And longest dot val equals sum minus 10 was 14, so we equal 4. Right? And so that would be perfect. And the last thing we'd have to check is basically after the loop, if carry does not equal 0, right, then we want to then we can actually do while shortest, we'll do while shortest not equal null, or carry does not equal 0. We could do one more iteration, and then we could actually do this. If we did it safely, we could say long.val safe navigation, or 0. So if the values end up actually existing, it would just be 0, and we'll do that extra iteration to do that final addition. And we could make this whole thing safe if we do, we'll say if shortest, and if shortest actually does exist, then I'd never actually, oh no, we ran out of time, I forgot. We move this up, and then I'd make this one safe as well. And then at the end, we should be able to return head. And I'm feeling good about this one. I'm feeling good about this one. Like relation or statement expected. Line 59. So the semicolon was expected. Sum is greater than 10. Oh God, else if. Line 15. This is LL, just a bunch of many more extra leftovers. Hey, yeah. All right, we'll see. Oh, I got too hype. Oh man. Right. So if longest, damn, this is kind of tough. sum is greater than 10, you want to set that value, right? But there's two cases where we set that value. And it actually doesn't matter if it's 0, right? Because we don't care about creating a node. But if longest is actually null, which means we have to extend the number in the case of all 9s, we have to extend it. Then what we want to do is just say longest equals new list node. And let's check the parameter for that. It just takes a val, so we'll just do sum minus 10. Actually, longest dot val equals sum. It's actually right here, I was gonna say. But it's in both of these cases, basically. It's greater than 10. I'm pretty sure you need it in both cases. Feeling good about this one. Please, LeetCode gods, please. Oh, man. Equals 18, but it didn't continue the carry. Carry does not equal 0. Carry does not equal 0. Which in all of these cases, it should still be going. Yeah, we're supposed to add one more node at the end. Oh, wait. Yeah, this is actually fine. I think I'm actually just trolling. This is supposed to be longest equals longest, not sum. Because it's just an extension to create an actual node that exists. Oh, I think I see what's happening. It could be that it should actually be carry. It's the case where you can actually carry more than one number. And so I'm just setting carry equal to 1, but I should be propagating that. So now I am actually adding that extra node, except oh man, so close. Maybe it's not that. So close, so close. Oh man, I was feeling really good about this one, but I think it's probably a good spot to read the solution. Elementary math. Yep, I knew it, man. I knew it. Keep track of the carry using a variable and simulate digit by digit sum starting from the head of the list, which contains the least significant digit. Visualization of the addition of two numbers, 3, 4, 2, and 4, 6, 5, but they're already reversed. We begin by summing the least significant digits, which is the head of L1 and L2. Overflow example 5 plus 7 equals 12. The current digits to 2. Bring over the carry equals 1. Next iteration. Carry must be the 0, 1, largest possible sum of two digits. And the carry is 19. Yeah, I don't know what type time I was on with carry plus equals 1. The pseudocode initialize current node to dummy head. Initialize carry to 0. Initialize P and Q to head. Oh, I just realized I didn't have to do the shortest one because it's already reversed. They're starting at the least significant of both. Move to list L1 and L2. Update carry equals sum divided by 10. Oh, create a new node with the digit value of sum mod 10 to get the remainder. That's my problem, was I was doing minus 10. I think. Then advance the current node to next, advance both P and Q. So they just, oh. P does not equal null or Q does not equal null. Right, we're defaulting to zeros. I did a similar thing here. We do the sum, x plus y plus carry. And then if you just do mod 10, you can remove all these if cases. Sum carry equals sum divided by 10. Well, you want that as an int. But what you actually want to keep on the number is actually sum mod 10, which would be the remainder, which should be 4. I'm doing sum minus 10. So I think I can compress all of these into carry equals sum divided by 10. And then longest dot val would actually, I'm trying not to look at what they just said. Carry would equal sum mod 10. Longest dot val would actually just be equal to the sum, but mod 4. I wonder if this was the missing cheat code. Oh, right, and we forgot to do the final thing, which I erased. If not longest, then we'll just create longest equals new list node with sum mod 4. Oh, this needs to be, do it like this. So this, so what are they doing here? Sum carry equals sum divided by 10 equals a new list node. Sum mod, oh, not mod 4, mod 10. Oh man, this is still slightly wrong. Say parse parameter of type string. Or we'll just say math.floor, I guess. Equals sum mod 10.